Okay. Good morning, everyone. I am Jesting, the product manager of HD Rocksand. HDXRF technology in soil and water analysis. This is a new site characterization tactics. I'm very happy here to share with you this new technique, a breakthrough technology in soil and wastewater analysis. I will introduce these four parts during the presentation. The first part is introduce HDXRF technology and with the principle, what is the advantage of technology. And then second, I go through the product HD Rocksand, what is the feature, advantage, and benefit of HD Rocksand. And then I will introduce you HD Rocksand application. In what kind of situation will use this kind of technique, this machine, and what kind of value it can create it for you. And for the last step, I will introduce you some real case study we have done before. A technology overview. HDXRF means high definition X-ray fluorescence. So what is X-ray? X-ray is it's a microwave and with wavelength from 0.01 nanometer to 20 nanometer. And this is X-ray, and it is very commonly used in our daily life. Sometimes we need to go to the hospital to get the CT examination of our body. So that is using X-ray, and it just use the image technology of X-ray technology. And for XRF, it means X-ray fluorescence. What is XRF? What is X-ray fluorescence? So we can check the atom system. One primary X-ray is shining on atom is the sample for. There are many elements in one sample, and each element there will be atom of the element, and the inner part of the electron in the element will goes out of the atom because of the atom absorb the primary X-ray radiation, and after that there will be a hole in the channel. So it is the atom is not in a stable situation. It will the outer layer of the electron will goes into the inner part, and because there will be energy difference between different channels, different channel of electrons. So the gap of the energy will emit by X-ray fluorescence. So we call this X-ray fluorescence. And from this point, we can see XF technology is analyzing the total element concentration, and it will not give us result for different compound or chemical valence of the atom of the element. For example, chromium 3 plus 3 valence and plus 6 valence, and we just XRF can give the total concentration chromium element, but we cannot distinguish how much 3 plus and how much 6 plus in it. And for XF technology, what's the analysis range of that? For element range, for this technology, for on-site and for portable one, generally it starts from periodic element periodic table 13 from aluminum and to the 92 uranium. So the range of element analysis is very large. For all of the heavy metals in soil, XRF is a proper tool to analyze. And for the state of the samples, you can analyze both solid sample and a liquid sample directly. And this also wonderful because most of the analysis tools, they can analyze either solid or liquid, and they cannot analyze both of the states of samples directly. And for the concentration range for XRF technology, I think it's a very wide dynamic range of analysis from 0. ppm and to 100%. It is a very large range. And for HDXRF, and its advantage is in the low concentration part of XRF technology, and it can give better results of 0. ppm and ppm level concentration of elements. And from this picture, we can see what is the basic principle and what is the structure of the instrument for the traditional, we can call it the first generation portable XRF technology. And there's a tube, means the source of X-ray. And the source of X-ray is emitting some mixture of different energy X-rays and on the sample. And the sample, the elements in the sample absorb the X-ray and they emit their own X-ray fluorescence. And we use a semiconductor detector and to collect all the information of the fluorescence. And for this first generation XRF technology, it is very simple, but it is very convenient to use. However, there's a difficulty to analyze very low concentration elements because it has very limited sensitivity. And here is the structure of HDXRF, and there's a spectrum comparison between the first generation and the second generation XRF technology. First of all, we can see the principal diagram of HDXRF. It is different from the previous page, and we can see there's one DCC crystal. The full name is double curve crystal, and this crystal can greatly help to improve the performance of the whole X-ray system. It has two functions. The first function is to monomize the X-ray source, because we can see in the X-ray from X-ray tube are different colors. There are different colors of the X-rays, means different energy or different wavelengths. It's a mixture of different X-rays. And after the DCC crystal, and there's only one color, because there's the main function of the DCC crystal. It can monomize the X-ray source. And the second one, second function of DCC crystal is to focus X-ray, because the source of X-ray is emitting like a bulb, and we cannot use most of the energy, so we will lose a lot of energy for the first generation. But with the help of the DCC crystal, and we can collect and focus most of the energy, and focusing on a very small point on the sample, so this we can increase the X-ray excitation efficiency. And both of the two functions of the DCC crystal, it gives a very high sensitivity to ppm and sub-ppm level elements. We can see the spectrum comparison, and for X value, it represents keV energy of X-ray fluorescence. In different positions, elements will locate in, and for the Y value, it is count received by detector, and the higher means the higher concentration of one element and in one sample. And for the black curve, you can see it's the first generation. For the red curve, it is second generation. And we can clearly see for ppm level elements like nickel, copper, zinc, lead, bromium, such kind of elements, with the second generation, ppm level elements can have very good peak, and it has a good peak to background ratio, so that we can do qualitative and quantitative analysis for the second generation, while in the black curve, the ppm concentration signal is buried in the large background noise, so it cannot analyze so low concentration. And there are 8 key technical advantages of HDXRF. And first one is no damage to sample. And this will be especially useful for analyzing some precious samples, like a precious metal, like we can ring necklace, such kind of thing. And also, the second advantage of this technique is a very short test time. For screening, generally we can use half minute to do screening job. We can get a general idea of what are the possible contamination elements in soil and water. And if you want to have better results for quantitative purpose, then we can have 10 to 15 minutes. But compared with other techniques, it is a relatively short test time. And the test is very high precision and with a very wide dynamic range. And for this kind of technology, it can both do lab analysis and portable analysis. It is very flexible. And it can test both liquid and solid samples directly. And this technique, it is different with the lab analysis method. It does not need, or just a very simple sample preparation. No need to use acid to digest the soil samples. We just grind it and sieve it and test it, and it can give us the same result for ICP or AS or ICDM method, such kind of lab analysis method. And for the running cost, it is very low because such kind of technology, there's almost no consumables. We do not need to use any acids and some other gas or something. And the last one, this kind of instrument, it is very easy to operate, which means that we do not need any chemical background specialist to operate. Just the common people. We give him half an hour to 1 hour training, then he can use this instrument quite well. And these 8 points, I think it is very important for the technical advantage of HDXRF. Now we go to the product part. And here we can see in the middle, there's a picture of the product, and there's a gap in the middle, and it is the X-ray source and the high voltage and detector assembled in the GAN. And there's a HIM interface to connected a cable with the GAN to control and do data process and display the result of the sample. And there's a test stand. Test stand, it is very safe for operators to use because X-ray, though its power is very small, but it can have some scattering X-ray, and it may harm for some operators if we just use GAN to do screening for a long time. But if we are using a test stand with power on it, so it is 100% safe, no radiation worry. And also, this kind of instrument, it is designed for both laboratory use and portable use. So there's we can use it easily, and its handheld capability is high. And there are 3 testing modes of HD Rocksand. There are 3 modes. The first one, just similar with the first generation X-ray. We just use GAN to shoot to the ground directly. And in this mode, we just to do screening job. For the result is just for qualitative analysis. And a second mode is to analyze soil sample in some plastic bag. And in some situations, customer like to put samples in a sample bag and ship them back to the laboratory. So in the laboratory, they can put such kind of thing in the test stand and test give a result. And for this test, and it because without the handshake and some uncertainties, so the results are relatively stable. So results are better than the GAN mode, more stable, and with higher repeatability. And for the last one, we call it quantitative analysis mode. We put soil sample, or wastewater sample into the sample cup and put the sample cup in the rotator platform, then put into the sample chamber and close the cover and to test. For this one, it can give a quantitative analysis range, and with the help of the rotator, we can analyze much larger area of sample, which means that we can compensate some unhomogeneous distribution of heavy metals in the sample. For HD Rocksand, there are some key features of the product itself, and there are special designed for soil application. And with the rotator mode, we can analyze a large area, and there are 2 fans installed on the test stand, because for some, especially in summer days, if we go down to the field and work for a couple of hours, and for the first generation, we cannot use it for more than half an hour, because the tube will get hot very fast, and we need to have a rest. We cannot work continuously. So we install 2 fans to solve this problem. And there are also 3 flexible testing modes that I just introduced. And also there are shooter bag and on-site screening case, 2 ways for customer to choose to take on the sample, or take on to the site. If we just want to do screening job, we just put the GAN into the small carrying case with a cable and a battery. We just go onto the field site to do a screening job. It's relatively easy. And if we want to do a quantitative analysis, so we need to take the shooter bag and take the test stand and the GAN together and take onto the site. It is heavier than the screening carrying case. And also, there are some built-in color alarm. If the result of one certain element is exceeding the regulatory limits, and this can help the operator to check if there are some problems of the sample of the soil they have tested. Because in different areas, there may be different regulatory limits, so that some operators, they are not well educated, or there are too many regulations. They cannot remember all the elements, concentration limits for all the regulatories. So, this function can help the operator distinguish if their samples are exceeding the limits number. And also, for this kind of product, you can analyze the soil, solid waste, and some plant and water analysis. There are many types of samples they can analyze. And also, for different contaminant elements, there will be some specific optimization mode. For example, if we will analyze very low concentration cadmium, so there is one cadmium optimization mode, which can give much better performance for cadmium element. And the second great feature of HD Rocksand is a strong technical performance, and this is our most strong point. It can provide more than 10 times the sensitivity than the first generation handheld XRF. And also, it can have a strong anti-interference capability, such as the influence from lead to arsenic. As we know, there are many contamination grounds. Lead concentrations are much higher than arsenic, and there will be a spectrum interference between lead and arsenic. And for the first generation XRF, it is difficult to process such kind of problem. But for HDXRF, it can give much better results. And also, there's a standard test method and practical experience. And we have just applied for ASM method, and I will introduce this later. And also, XOS company has already have more than 20 years of the XRF analysis experience, and we have many site investigations and remediations project experience in both U.S. and China. And here we can see we test at regulatory levels. Pollutants are, we can take arsenic and cadmium and mercury, for example. The Shanghai standard and RCRA levels can see the numbers are relatively low with these kind of elements. And for XOS quantify LOD, we can see the number is really low, 0.5, 0.8, and 0.5 for all these elements. And for screening mode, it is 3 times larger than the quantified mode. And for the first generation XRF, we can see the number is very large. It has almost 10 times larger of the LOD of the second generation XRF. So, which means when we are analyzing samples with the help of the second generation, we can meet all the requirements of the regulatory limits for almost all the elements. But while for the first generation, we can just do some screening job, but it's not that precise enough, I think. And also, we can have some liquid test capability. And for this unit, it can give elements analysis result for solutions with LOD on the right column, HDXRF LOD. The number for most of the elements is 0. ppm level. And we can see in China, industrial wastewater, and there's a first class and second class limits. And most of the samples limits, and I think XRF HDXRF can test it well. And also there's a solid waste solution. There will be some limitations of the samples, and we can do some help for analyzing such kind of liquid samples directly. And we are applying ASM method, and this method is a new test method for elemental analysis of soil solid waste by monochromatic and dispersive X-fluorescence spectrometry using multiple monochromatic excitation beams. And the number we can see is ASM WK 53148, and we can get access to the website and we can see this. And right now we are on the third round ballot, and hopefully we can get this done this year before, I think this year we can get this done. And the next part, we can compare what is the advantage of HDXRF compared with lab testing. And there are some lab testing limitations. For lab testing, we know that generally we need to send samples to the laboratory. We get some remote area to get the samples and send the samples to the laboratory, and it can cost us $50 to $150 US for 8 or even more heavy metals per sample. And also it can take us 1 week or 2 weeks to get the whole results, and so that it is very time consuming and it costs money, and it can be a problem for a large investigation or remediation site because it's too large area, and we cannot ship all the samples to the laboratory, because if we are doing so, we are wasting too much time and money and delay decisions while awaiting for the analytical results, especially for some contamination source identification. Generally, portable XRF is very useful for such kind of application because it is quite easy and it can analyze the boundary of the contamination source easily, and it's the best advantage. And compared with the first generation handheld XRF, what is our advantage? And I think the advantage that there are almost 2 points. The first point is very high sensitivity, because handheld XRF, the first generation analyzers, they are not able to meet the analytical requirement and the regulatory limits in soil for mercury, arsenic, and cadmium, and also almost all the elements in industrial wastewater regulation. And HDXRF, the second generation, can do this much better than the first generation. And also, we can get some, for the second generation, we can solve spectrum interference problem much better. And there are some applications of the HD Rocksand unit. And the first one for environmental monitoring and enforcement, and the pollution source monitoring, and land survey of a nation, and an emergency inspection of some accident. And the brownfield projects, we can do site investigation of the brownfield and the remediation process control. And also, when the project is finished, the project completion inspection from government or from third-party institute. And also, there are some researchers in college, some professors, some other people are doing research on remediation technology and on some contamination and ecological influence of heavy metals. Here, I will introduce you a little bit about the site investigation and remediation. There are several phases, different procedures of the site investigation and remediation. For the first and second part, we generally are doing an environmental site assessment, and we need to investigate the site history, what can be the possible contaminants, and review the process of waste have been discharged, and we can have a general idea of that to check if this area can have high risk to be contaminated. And for the third phase, that detailed investigation and remediation plan. And here is one example. We can see there are two. There are two contaminants in this factory, and the organic, both organic and inorganic. For the green color, it is organic, and for the orange color, it is inorganic. And for this case, it is mercury. And we can see with the help of HDXRF analyzer, the customer can draw very clear boundary of the contamination source of the whole map. And so we can call this a detailed investigation. And after we have done this quite well, then we can make a very good remediation plan. So we will not waste some money and to have some high risk because of the not good enough investigation. And for the fourth part, and the remediation will be performed. And generally, for some remediation projects, and the customer need to, the engineers there on site, they need to analyze the heavy metal concentration while they are doing remediation. Also, it depends on what kind of technology they are using remediation. And for the last part, remediation verified, and a brownfield has just been finished remediating, so that it needs inspection from some government-owned institute or third-party institute. And before they give the sample, submit the result to the institute, they need to check themselves. And generally, after remediation, the concentration of heavy metal is very low in this part. So the first generation XRF cannot do well, but the second generation can do this much better. And here I will introduce you some practical data and the influence factors. There are different types of soil samples there. And here we can introduce some reference material repeatability test is NIST NIST samples. And we can see for pretty low concentration nickel and cadmium, and we can get a RSD as a close 6% or 3%. It's very low. And for this another NIST reference sample, for mercury, it is very low concentration, as low as 7 ppm. And this cannot be analyzed by the first generation, but we can test it quite well with RC around 4%. And here, oh my God, here is some real data we have done in China. We have tested around 15 reference material, and we draw a picture to see what is the result performance, and we can see, there are some errors here and we cannot see. But for the X value, it means the test result of HDXRF, and for the Y result, it means the certified value of reference material. And we have tested many samples. We can see the two results correlates with each other very, very well. Here is for some practical sample tests. We test some real samples. Here is the result. We get some samples from different brown fields, and we get them back, and we process them and to dry, to mesh, and to 100 mesh, to sieve to 100 mesh, and then we send the sample to 3 third-party laboratories, and also we test with HDXRF. And after a test, we can get the full result. We can see for the most of the results, these 4 results are almost they correlate with each other very well, and there's no big difference for each one. And if we look at these numbers seriously, we can find some problems of the lab analysis. For the lab result and the lab 1, we can see the result of lab are almost twice the number compared with lab 2, lab 3, and HDXRF. And there's a system error, I think, because I do not know if they have made some error during the process of the sample. And for the zinc, we can check the lab 3 result. We can see the result of zinc in lab 3 are almost 50% higher than lab 1, lab 2, and HDXRF. So this is a limitation of the lab analysis. If we send even the same sample to different laboratories, we can get some different results. But for HDXRF, it is quite easy. And no matter who is operating, no matter which machine of HDXRF, if we are analyzing the same sample, we will get the same result. Okay, and here is a picture of correlation of these elements. Okay, here is one real site case result, and SP01 means the region, contamination 01, contamination region 0203, and with the number means 3.2 meters deep and 7.9 meters deep, like that. And this is contamination of arsenic field. And we can see a correlation between HDXRF and ICP result is very nice, and it's higher than 0.9 R square. And for HDXRF first generation, we can see it can give accurate results. Only one concentration of arsenic is higher than 30 ppm, but below that, it cannot test well. There may be very large error, or just give an indication of lower than OD. And here is a 2 ppm CRM solution for ICP use, and we can get the result as a test for repeatability check. And HDX can have the capability to analyze ppm level solutions. And there are some influence factors of XRF analysis for soil. And the first one we can call heterogeneity between samples, which means that heavy metals are not distributed homogeneous in soil, which means in different area, it can be very different concentration of the heavy metal elements. And the second one we can call, so that there's a problem. There's for soil sample representativeness, because for lab analysis, we are using just 0.5 gram samples, but it represents almost 500 gram samples. So generally, how can 0.5 gram represent the average result of the 500 gram? So we need to use very strict process of the 500 samples. But actually, in many laboratories, they are not doing this strictly quite well because it costs them much higher labor cost and time cost. But for HDXRF, with XRF technology, it can analyze much large area and much quantity of the sample so that it can use better representativeness. And there's another effect influence factors. We call it heterogeneity within sample, which means that in different particle size in one sample, we can say 10-gram soil samples we get from one field. And in 10-gram samples, we separate them into different particle size with 4 mesh, 10 mesh, 200 mesh, and we check the concentration lead in each particles, and we can find the results are quite different. This is a common conclusion that in very small particle size, the concentration of heavy metals are generally much higher than the large particles. So if we are analyzing directly of soil samples for heavy metals result, which means that we are analyzing the average result of all size particles. But when we send this sample to laboratory, and laboratory will process the sample, will analyze the average result of small particles going through 60 mesh in the US and 100 mesh in China. So we XRF, we test directly, and the sample sent to the laboratories, we are analyzing different samples. So generally, sample result will not be the same just because we're analyzing different samples. But if we're analyzing the same samples, probably we can get similar results. Oops. In this slide, okay, thank you. Sorry for the internet problems all of a sudden. Thanks for your help on this. For soil sample preparation for quantification, there are generally these steps. The first one, we need to dry the sample because there are many moisture in the sample, water inside, and we need to dry it. If we want to do it fast, and we need to use an oven to make the dry process much faster. But it's not good for mercury test because when the temperature is higher than 60 degrees centigrade, mercury can evaporate into the air. And the second step is to grind the soil into small particles. And the third step is to sieve it with a mesh. There will be a standard operation method in different countries. So we need to check the technical guide, regulatory process, then we just follow it. After that, we get very teeny small particles, then we can do quantitative analysis, and we can get same results for with ICP or ICP-MS method. Next slide, 36, please. And also, there's another influence factor, we call it moisture effect. And the different moisture can cause a result different. And so there's a trend for all the elements. If water concentration is going higher and all the results of all elements are going lower, we can see in general 40 to 60% moisture can be the maximum in soil samples. it depends on different type of the soil. And the moisture can cause result lower for example, 20% moisture can cause about 20 to 30% result lower. So when there's moisture inside soil, we know that the result will be lower than the fact, then it is dried. Next slide, please. 37th slide introduce you briefly about a Geneva Foundry case study in the U.S. And this is a large area contamination field, and the customer is using HD Rocksand unit and to do site investigation of a very large area. And the area is contaminated with arsenic, especially relatively low concentration. Next slide, please, 38. And there are a few key challenges for the project. First is a very large number of samples are needed to characterize the area of interest, because this is a very big area, and there are a lot of contamination source can be. So if we cannot get so many samples sent to the laboratories, and for the first generation, it is too low for the first generation to test. So it is a big problem for the customer. And just with the help of the second generation XRF, they can do screening very fast. They can do the characterization of this potential contamination area. Let me see. Next slide. A solution, and the DEC already has the ability to quickly and easily measure soil samples of lead and infused using portable XRF technology. Generally, the regulation control for lead element is relatively high. So the first generation XRF can do lead well, but it is not good enough for measure arsenic at a regulatory limit. So in Geneva Foundry site, so that is why HD Rocksand was used. This technology use robotics to lower background signal and produce better performance of that. Okay, I'll just skip this. Slide 40, Connie. And here we get the comparison results of ICP and HD Rocksand for arsenic on the field, and we can see generally the concentration of arsenic is very low. For background value, it's about just several ppm or just more than 10 ppm. And if it's contaminated, it can go as high to 50 ppm. And here is the correlation picture of ICP method and Rocksand unit. And we got the comment from customer, with the money spent on the site, we could buy one HD Rocksand, complete the investigation in 1 week with a few laboratory confirmatory samples. Here, I think HDXRF can help us to greatly reduce the samples we send to the laboratory, but it does not mean that we can replace 100% of the lab analysis. Okay, also next slide, 41. And we have also done a lot of experience and cases in China. We have some dyeing factory for chrome contamination and some cornfield for arsenic contamination, also for one chemical factory for mercury contamination. Okay, thank you. Connie, I have finished the presentation.
Yes. Thank you very much, Justine. And we have just a few minutes for a couple of questions. And Bridget, I have your line unmuted also. Our first question, what makes the HD Rocksand different than other HDXRFs?
Just quickly to answer that would be the, lower detection limit that you would see. Typically, it's about a 10 times higher sensitivity. with the technology that we use with the HDXRF.
And our next question, what is the weight of the HD Rocksand?
It's less than 6 kilograms, or it's about 13 pounds.
How many scan can the analyzer hold?
Typically, we have an SD card that's in the analyzer, and it can hold about 10,000 screens.
And let's see. I have one question. Can lithium be detected?
No, we cannot do lithium.
Okay. And we have one. What are the cost differences between the HDXRF and the HHXRF?
I'm not familiar with the pricing for the HHXRF, as we do not manufacture that, but the HDXRF is about $64,000.
And I believe we have time for one more question. Does humidity of influence results? How can we get better results in various humidity?
We want to keep the moisture as low as possible, so if it's under about 20% moisture, we should be fine. But if you're in the field and you can lay out the sand or dirt just to get it as dry as possible, works fine.
And that does look like that is the end of our questions.